Hello students, today we will discuss Biot-Savart Law in chapter Magnetic Effect of Current. It is Biot-Savart Law and actual pronunciation is Biot-Savart Law. It is also known as Ampere's theorem or Laplace law. So remember all these three names: Biot-Savart, Ampere theorem and Laplace law. It is developed by Jean-Baptiste Biot and Felix Savart. They derive an expression for magnetic field due to current element AB. Here is the current element AB. The current is passing from A to X to Y and it is I. So the current element is AB. It is a very small element and its length is dl. And we have to find out the magnetic field intensity at point P. So the magnetic field at point P will have direction and the direction will be crosswise. This is because of the right-hand rule. If current is in thumb, the magnetic field of induction will be on the finger and vice versa. It means the current is in this direction, then the magnetic field will be like this. So the magnetic field here, it is crosswise. So in right side of this wire, the magnetic field is crosswise. It means into the page. So here is the magnetic field. dB, because of the element dl, is crosswise. The line of joining between element to P is represented by R, and the angle between them is theta. Here theta is the angle between element length AB and the line of joining AP. According to Biot-Savart law, the magnitude of magnetic field dB is directly proportional to the amount of current. More the current, more the magnetic field of induction, and is directly proportional to the length of the element. Inversely proportional to square distance between the element and the point. And directly proportional to the sine of angle between element and the line of joining, that is theta. So magnetic field at point P is proportional to current, it's proportional to length element, is inversely proportional to square distance, is directly proportional to the sine of angle between element and line of joining. Now get together what we will get. We will get dV is proportional to I dl sine theta upon r square. So we have to remove the proportionality sign now. Then dV is equal to a constant. IDL sine theta upon r square. Here, the proportionality constant is mu naught upon 4 pi. So dB is equal to mu naught upon 4 pi IDL sine theta upon r square. So this equation is used to find out the magnitude of magnetic field of induction because of the current carrying wire. Here, mu naught by 4 pi is constant and mu naught is called permeability of vacuum or free space. The direction of dV is perpendicular to both the element dl and the line of joining vector r. In vector form, we may write here dV is equal to mu naught by 4 pi I dl sine theta r vector, as dl is also vector, upon r cubed. We multiply it and divide by r right hand side. Or dV vector is equal to mu naught by 4 pi I dl vector sine theta r unit vector upon r square. The value of mu naught by 4 pi, that is the proportionality constant, is 10 to the power minus 7. Its unit will be Tesla meter per ampere. How we find the unit? dB is the Tesla, I is in ampere, dl in meter, and r square is meter square. So mu naught by 4 pi Tesla meter square upon ampere meter. So meter cancel, then you will get Tesla meter per ampere. The direction of dV will be also given as right hand rule. Now, in next part, we will use the application of Biot-Savart law To find out the magnetic field of induction due to current carrying circular coil on its axis, on its center, and in your syllabus, magnetic field due to long straight current carrying wire. Here is a current carrying wire. It is XY. It is carrying current I. And the wire is a straight long wire. And we have to find out the magnetic field of induction at point P by using Maxwell's right-hand rule. It will be crosswise, that is into the plane of paper. AB is the element, it is dl. AP is the line of joining, it is represented by R. Theta is the angle between element and line of joining. AP and BP are very near to each other because dl is a very small element. So the angle theta is here, will be also at point B. So angle BABP will be theta, or we may write angle ABN as theta. How theta is there? Again, here is theta angle between element and R. Because element is very small, it is just point-like element. So A and B are coincide here. So there is the angle theta at point B will also theta. Now we try here and another angle phi. It is angle ABO, this angle. We will take this angle for help of derivation. Now, from Biot-Savart law, at point P, what we will get? We will get dV is equal to mu naught by 4 pi I dl sine theta upon r square. Now in triangle ABN, look the triangle ABN. We will have sine theta is equal to AN upon AB, and AB is dl. Sine theta is perpendicular AB, hypotenuse AB, and AB is dl. So we may use this value of sine theta into Biot-Savart equation. So dV will be equal to mu naught by 4 pi I dl upon r square into AN upon dl. Now dl cancel each other. So the equation became dV is equal to mu naught I an upon 4 pi r square, right? Now theta is phi is the angle from minimum distance OP to the element AB, and element AB is making a very small angle d phi. So from triangle A and P, we will have from this angle, this is perpendicular and AP is hypotenuse. So sin phi, sin d phi is equal to an upon r. Where angle are very small, then sin d phi will be d phi. So d phi is equal to an upon r. So in place of an, we may write here r d phi. Remember, this delta phi is very small. So for a small angle, sin d phi equal to d phi. So the value of dB is equal to mu naught upon 4 pi I. In place of an, we may write here r d phi by r square. So r and its square will cancel here. So dB is equal to mu naught by 4 pi I d phi by r. Now look this figure again. We have triangle POA. We are using again the triangle. Another triangle, it is POA. Here you will get cos phi is equal to base, that is A, and hypotenuse, that is R. Cos phi is base, that is A distance, upon hypotenuse is R, or we may say R is equal to A by cos phi. Now we will plug this value of R into this equation. So dB is equal to mu naught by 4 pi I upon value of A is R is A by cos phi, and d phi is here. Hence, dB is equal to mu naught by 4 pi I by A cos phi d phi. Now for the complete wire, if we further discuss, the complete wire starting from X to Y, the angle phi changes from minus phi to phi 2 here. So we will integrate the magnetic field of induction dB for angle minus phi 1 to phi 2. Thus our limit will be minus phi 1 to phi 2 or phi 2 to minus phi 1. So dB is integrated for complete wire, and it is minus phi 1 to phi 2 mu naught by 4 pi I by A cos phi d phi. So B is equal to mu naught by 4 pi I by A. All these are constant. I is current flowing on the conductor wire is constant, and the minimum distance of point from the line is A. It is also constant. Mu naught by 4 pi is already constant. So we will have integration from minus phi 1 to phi 2 cos phi d phi. So you will get it is mu naught by 4 pi I by A sine phi 1 plus sine phi 2 in Tesla. Thank you.